solving a system of a linear equations. Example of a linear equation. So this is an example of two equation with a variable x and y, and this is three equation with a variable of x1, x2, and x3. So in general, a system of m linear equation in an unknown can be conveniently written as, okay, we have first equation, second equation until m equation with the variable of x1, variable 1, x2, variable 2 until xn with n unknown variable. So using augmented matrix, we can define the above system as follow. Okay, so we can write the system, the linear equation into augmented matrix, where this column refer to the first variable, which is x1. This column refer to the second variable, which is x2, and until n column, which is variable xn. So to solve this system, we can use a Gauss elimination with a back row substitution, or we can call it row echelon form. So Gauss elimination method with a back substitution is a method that uses a row operation to transform an augmented matrix into row echelon form, and then use back substitution to find the solution of the system of linear equation. Okay, so we will use a Gauss elimination method and then use back substitution together with as one of the step to solve the linear system. Okay, so we have 4 steps. Okay, step 1, write the system of a linear equation as an augmented matrix. Step 2, use a row operation to rewrite the augmented matrix in a row echelon form. Step 3, write the system of a linear equation that corresponds to the matrix in a row echelon form found in a step 2. And then last step, use the system of a linear equation found in step 3 together with back substitution to find the solution of the system. Okay, so let's look at the example for two equations. So we have two equations. We will try to use Gauss elimination with back substitution to solve the system. First, write the system of linear equation as an augmented matrix. So we write is 2, this is referred to 2x, y equal to -8, x plus 3y equal to 6. Okay. And then we use row operation to rewrite the matrix in row echelon form. First, as we see, we want to make sure the first row, first column, our target is we want to make sure this one equal to 1. But we can see that we have 1 and at the second row, so we just can interchange the first row to the second row and the second row to the first row. So we interchange, we get 1, 3, 6, 2, 1, -8. So now we are focused on row 2, where our goal is we want to make this entry equal to 0. So by using the formula, we will write as row 2. Okay, you write back your row 2. Okay, so to make sure this equal to 0, we know that our target is 0. Okay, our value for row 2 is 2. So we use row 1. So our value now for row 1 is 1. So this one will be To make sure this equal to 0, you need to minus with 2 times 1. So your equation will be minus 2R1. So this is your equation as row 2 minus 2 row 1, where you can get this when you do the operation using this equation to get all value of this row. Okay, so you can just do one by one for each entry. Okay, 2 minus 2 times 1, you get 0, and then 1 minus 2 times 3, you get negative 5, and so on. Okay, next we want to get this part equal to 1. So directly we just can divide with negative 5. So your row 2, you write by row 2, you will get negative 1 over 5 times row 2, and you will get the answer. So since we already have the diagonal equal to 1, so actually we can write the system of linear equation corresponding to the row echelon form of the matrix, and the result as follows. So you get this equal to 1, so you can write this as x plus 3y equal to 6, y equal to 4. Then use back substitution to find the solution of the system. Okay, so when we have this equation, we just can we have y equal to 4, therefore we can find x by substitution y in this equation. Okay, so you get x plus 3 times 4 equal to 6. So substitution 3 times 4 equal to 12. You bring to this side, you get negative 12. So 6 minus negative 12, you get negative 6. Thus, the solution will be x equal to negative 6 and y equal to 4. The next example, we use again the Gauss elimination method and also back substitution. So first we use the row operation to rewrite the matrix in a augmented matrix. So you get an augmented matrix. Okay, but you see then this before we start, we see we have 1 here, so we just can exchange the value, the all row 1 to row 2 and all row 2 to row 1. Okay, next we want to make sure this equal to 0. Okay, and so you can do row 2. So row 2, we can use row 1 here. So row 2, you want to make sure it's equal to 0. Row 2 value now is equal to 2. Row 1 is equal to 1. So you just can minus with 2. So 2 times minus 2 equal to 0. Okay. We also can look at this 3. So we can use row 3, and row 1. Okay. We have row 3 equal to 3. This is equal, we want to make sure this equal to 0. So this, now the value here is equal to 1. So we just can minus with 3 times 1 so that it will be equal to 0. So row 3 minus 3 row. So you get the equation. So you can do the operation at row 2. And then you can do the operation at row 3. Okay, so you get the answer. You can proceed to get this value. So we make sure this equal to 1. So this is directly, you just can divide row 2 equal to row 2 divide with 3 and proceed to the change the all row 2 value with the equation that been created. Okay, so next we will make sure this equal to 0. So we'll look at row 3. So row 3 minus row 2. you can get the answer. And then last, we have to make sure this equal to 1. So we just divide all row 3 with -7. So row 3 is equal to -1 over 7 times row 3. So as we change this, all the row will get this. So we write the system of a linear equation corresponding to the row echelon form of the matrix resulting as above. So we know that our variable here is x, y. So x minus y plus z is equal to -2, y plus 2z equal to 1, and then z equal to -1. So we use the back substitution to find the solution of the system. So we can have this and solve the value of z. We have a value of z. Okay, substitute in the first equation, the second equation. Okay, we substitute z here equal to -1, so we get y equal to 3, and then we use equation 1 and substitute all these z and y in the equation 1, so we get x equal to 2. So thus, the solution of the above linear equation is x equal to 2, y equal to 3, and z equal to -1. So another method to solve the linear equation is by using the Gauss-Jordan elimination, which is also called reduced row echelon form. Okay, Gauss-Jordan elimination or reduced row echelon form is a method which is similar to the Gauss elimination, except for the last augmented matrix will be in the form of I, which is the identity matrix, okay, which has the same as order of matrix B, which is the size of the matrix. Thus, no back substitution is required. So to find the solution of the system of a linear equation. So here we didn't have to do the back substitution method. So first step, write the system of linear equation as an augmented matrix, same as before. Step 2, use the row operation to rewrite the augmented matrix in reduced row echelon form. And step 3, the solution of the system can be written by the corresponding element in a reduced row echelon form of an augmented matrix found in step 2. Okay, look at the example. So we use a Gauss-Jordan elimination method to solve the following linear equation. Okay, we have three equation with a 3 variable. Okay, so right in an augmented matrix, so we have this augmented matrix, and then we use the row operation to produce the matrix in a row echelon form. Okay, so this part is already our main goal is to make sure this part become identity. Okay, 1 0 0 1 0 1 0 0 0. Okay, so we want to make sure this become identity. So this one is 1. So now we focus on row 2 for row 2 at this entry. So we will look at row 2 equal to row 2 minus 2 row 1, and then row 3 equal to row 3 minus 3 row 1. Okay, so our equation, so row 2 we change all row 2, and then row 3 we change all row 3 using the equation that have been formulated, depends on the okay, next we want to make sure this equal to 1. So we just divide the row 2 with 2, so that the value here equal to 1. So change all row with the equation provided, and then you get that answer. Next, we want to make sure this equal to 0. So we can write as row 3 equal to row 3 minus 3 row 1. So as you see, row 2. We cannot use row 1 because if we use row 1, we will minus 0 minus 3 row 2. So we will change this value. So make sure we didn't change the value that we already changed. Okay, so we have make row 2 minus 3 row 1. Okay, so and then do all the value for row 3. Next, we will focus on row 3. This one, we must make sure this equal to 1. So just multiply with negative 2. Okay, so that entry, this entry become 1. Okay, so do all with row 3. Next, we'll focus on this part. So make sure this equal to 0. So it's a row 2 plus 7 over 2 row 3. And do all for row 2. And then we focus on this entry so that this will be equal to 0. Then we put as row 1 equal to row 1 minus 2 row 1. Okay. And lastly, we will do at this part. Okay. So we get this row 1 equal to row 1 minus row 2. And we get the final answer. So since this part is already identity, okay, so we can write as x equal to 1, x equal to, y equal to 2, and z equal to 3. So the solution is this for the linear equation.